Yeah, so good evening to all. So today we are going to see chapter integrals. Okay, the first class of integrals. So anyone can join new, no problem. So I hope screen is visible. Screen visible.
Yeah.
One confirm.
Yeah. Visible.
Okay, so we are going to start the chapter called integration. Okay, so what we'll be seeing? We'll be seeing double and triple integral. 12th level, you saw single integral. Here we'll be seeing double and triple integral. That's the difference between school level and college level. So let's see what these are. Okay. First, I'll give some examples. We'll do basic questions. Then we will go to geometrical analysis. Okay. So this carefully. I'll give some total of 8 questions I have planned properly, whichever questions are required. So suppose I'm doing integral 0 to 1, x plus y dx dy. What you should understand is this is the inner integral, inner variable. So these are limits for inner variable, remember that. And this is outer variable, this one. So these are limits for outer variable. Okay. And when you are integrating inner variable, keep outer variable constant. So when integrating while doing this integration, keep y constant. That's it. These are the rules, remember, and try to do. It's very simple, but you need practice, correct? All simple only, but you need practice. So if you're keeping y constant, it will become x squared by 2 plus xy from limits 0 to 1 dy. Substitute 1, 0 and with 0, so 1 by 2 plus y. So y plus half dy. So this will be integral 0 to 1 finish integration, y squared by 2 plus y by 2 from 0 to 1. So this will be 1 by 2 plus 1 by 2 equal to 1. Okay, very simple, but you have to be familiar with it. That's it. Okay, I hope there's not going to be any problem in this. Next, look at this integral 0 to 2, integral 0 to 1, 4 xy dy, 4 xy dy, xy dx dy. First you observe carefully which is the inner variable. This is inner, so this is the limits for x. First you write like this, x equal to 0, x equal to nothing wrong. Okay, write like this, you will get more clarity. So I'm writing x equal to 0, x equal to 1, and here I write y equal to 0, y equal to 2. Now you can do this integral normally, but I would like to tell one special thing here. You are able to separate x and y parts are separatable. Clear? X and y parts are separatable. When x and y parts are separatable, you can split the entire integral into two parts. You can split the integral into two different integrals. I'll show you how that's possible. Look at this carefully. So if I'm taking integral 0 to 2, integral 0 to 1, 4 xy dy dx dy, what I'm doing is x equal to 0, x equal to 1, y equal to 0, y equal to 2. 4 I'll take outside. Now x part I'm writing like this, integral 0 to 1 x dx. Y part I'm writing separately, integral 0 to 2 y dy. You can do integral separately. You will get the final answer. Okay. This is the way of separating integrals when possible. See, the x and y parts are separatable. If that is separatable, you can separate the integral like this, and you can calculate separately. Look at this. What will happen? 4 into this will be, I'm writing directly. I'm not going to waste time evaluating integrals and all. This will be 1 by 2. This will be 4 by 2. So it will be answer is 4. I guess. See, even if the integral answer is wrong, I mean, now I am trying to do it faster. Just try to grasp the concept. Don't try to see the final solution. Okay. Final solution. Don't try to see. Okay. And I'll do one more question in this model. 0 to 2, 0, 1 to 3, 1 to 2, x y squared z dz dy dx. Be familiar with both double and triple. So this will be limits for z, this will be limits for y, this will be limits for x, because that's the order in which is written. This is the order. You should be very careful of the order. Based on this order only, you should write limits. Hope it's clear. Okay. What you will do? And separatable also. I'll separate it. For x I'll write separately. For y I'll write separately. And for z I'll write separately. Hope this is clear. So what will happen? This will become x squared by 2. It will become 4 by 2. This will become y cube by 3. Y cube by 3. What will happen? Y cube by 3. 27 minus 1. 26 by 3. This will become z squared by 2, 4 minus 1, 3 by 2. Okay, so this should be the final answer, I guess. Answer is 26, correct? Sit and solve slowly. If you are, I did it fast. And sit and solve slowly and check the answer. Okay, this is one concept. Now, next we are going to see. Till now we saw constant limits. You see carefully all these here. You're having constant limits. Till now that's what we were seeing. Limits are constant. But next model, I'll give variable limits also. Look at this carefully. Integral 0 to 1, integral 0 to x dx dy. In this circumstance, what you can do is ignore order. Why I'm saying is, look at this carefully. If x is here in the inner integral, x is there, meaning these limits are for y. These limits are for y because x is there, as x is in limit. Okay, so what you can do is write carefully. Look here. Integral x is 0 to 1. This will be y equal to 0 to x. Here you write dy first, and I'll change color so it's more nice. So this you will evaluate separately. Then outer integral will be from 0 to 1 dy. This is the way of integrating. So this, if you integrate, you will get integral 0 to 1. You will get x. What you will get? Oh, sorry, outer is dx. What am I writing? What did I write? Sorry, this is dx now. X equal to 0 to 1 dx. So this will be integral x dx is 1 by 2. Okay. All these type of model of integration you should be very thorough with. Okay, because only then we can enter to geometrical problems. If I do this, now listen carefully. Tell me, this also has variable limits. So first you divide this separately. This is for r, obviously. This can't be limit for theta. Okay, this is limit for r, and outer interlimit is for theta. Simple. Okay, integrate it. What will happen? R squared by 2. So you will get sine squared theta by 2, half into sine squared theta d theta. So you can apply this rule. First you take constant outside, integral 0 to pi sine squared theta d theta. Now you can write half into 2 into 0 to pi by 2 sine squared theta d theta. So directly I'll write as pi by 4. Now how I wrote this directly pi by 4, we'll definitely be discussing that. Please wait. And this also, it's this is and you use all the definite integral properties. I'll just write here. Use properties of definite integral. All those properties are 12 stat property. I cannot sit and explain all those properties here. Okay. So I used properties of definite integrals to do the question faster. Okay. Hope it's clear. I'm going very fast because there's very less time. Okay. So if someone is finding it very fast, then you watch recording, and when you're watching recording, keep passing and doing it. Okay. Only then you can finish the portion faster. If I teach like this, I can finish the portion fast. So please understand. So is it dx, dy, dz. So here in the limit itself, we are having y and z. So this should be limit for x. This is limit for y. This is limit for z. This is how you will segregate. Okay. And then you can do the question. Okay. I don't think I should waste time doing the question. Do the question. Okay. So 7th question. 0 to 1. 0 to 1, 0 to 1, e power x plus y plus z, dx, dy, dz. This question, can someone tell me how to do? I want some volunteer. This question, I want some volunteer. 8th question also I'll write. 8th question will be integral 0 to log a, integral 0 to x, integral 0 to x plus y, e power x plus y plus z, dz, dy, dx. Tell me how to do this question. Hello.
Separate into different integrals.
Very good. That's it.
Writing e x plus y plus z as e x into e y to z.
That's it. Over. Separatable, right? So you'll get the answer as e minus 1 whole cube, I guess. Is what the answer you will get. Simple. No confusion in this, okay? But listen carefully, don't get fooled. This question you can't do that. This question you cannot split into 3 integrals. Why? Because variable limits are there. Question can't be split. Why? Because there are variable limits. So don't rush the question. Okay, the moment you see it's you can separate, don't separate. Should be separatable. At the same time, you should have constant limits. You can only separate right here. You have constant limits. And second condition, you should have separatable variables. Only then you can separate the integral. Both these conditions should be satisfied. Even if one of these conditions is not satisfied, you cannot separate the integral. Please remember. Okay. So this question you will do on your own. Okay, I'm not going to waste time doing the question. Try to understand the logic behind how to integrate. These are the basics. Okay. This is the basics. Okay, that's it. Basics of integration. Okay. Yeah, one more thing is that which I'll finish off, and then we'll go to geometrical interpretation. I don't know how many of you would have heard this word. You may know the formula, but you may not have heard of the name of the formula. Look at this carefully. This formula is nothing but reduction formula. Look at this carefully. I want to integrate 0 to pi by 2 sine power n x dx. Okay. How to do integration fast? This is definite integral only. Okay. This is a standard result you have to remember, which I'm going to write here. Listen carefully. N minus 1 into n minus 3 divided by n into n minus 2 into k, and k will be 1 for n is odd. I'll explain, don't worry, just writing the formula. N is odd and k is pi by 2 for n is even. Please remember this formula. Ma'am has used this formula to do integrals faster in the class. Okay. Now let me explain how to remember this formula. Listen carefully. So you have integral 0 to pi by 2 sine power nx dx. You're having numerator by denominator into k. What you're doing is in numerator start with n minus 1. Denominator start with n. Keep multiplying by decrementing by 2. Stop at 1 or 2. These points, please remember. These points, please remember. So we'll see examples. Then it will be more clear for you. Don't worry. When you do example, it will be very clear. Suppose I'm saying do integral 0 to pi by 2 sine power 5x dx. Can someone volunteer? Volunteers, someone. See the formula on time. See the formula on time. And try to do the question. Start. Why no one volunteering? Someone volunteer.
4 into
4 into
2.
Numerator over. Denominator?
5 into 3.
Yeah, into 1 also. Yeah. 1 you can ignore another one. And what is the constant? Constant is 1, correct?
1.
Because it's odd. That's it, over. Integral is over. 8 by 35. See, 8 by 35. So 8 by 15. See how simple integral is, sir. 9 power 5. Imagine you're integrating without using this formula. Wow, it'll kill you. Okay, so this formula is very helpful. Now do this integral 0 to pi by pi. Integral 0 to pi sine power 2x dx. What do you do? If it is 0 to pi, this formula is going to work only for 0 to pi by 2. So whatever is given in the question, you try to convert it into what you require. Okay, so what you can do, you can apply property of different integral. You can say 2 into 0 to pi by 2. Someone is curious how I wrote 2 into, you see the graph, this already in 12th portion. Anyway, I'm just showing you. You see sine squared graph, it will be like this. And this is symmetrical. This area is same as this area. So I can write total area equal to 2 into left. That's what I have done. That's what I've done. Okay, if someone is curious how I'm writing, they're all probably different integral. Would definitely be knowing just to revise the concept I'm drawing, I'm showing. That's how I wrote this, okay? Anyway, continue. What is this? 2 into? I won't do all this. Someone should do. Come on.
2 into 1 by 2.
2 into? Numerator 1. Denominator you will have 2. And this is even, so you'll multiply by pi by 2 extra. 4. So answer is pi by 2. Okay? In between pi by 2. Now one more thing I want to tell you. Integral 0 to pi by 2. Suppose I'm asking what is cos per 4x. You can apply this formula. What is it called? You have one formula, we have one property of different integral. That is, we write it. Integral a to b f of x dx. You can write it as integral a to b f of a plus b minus x dx. You apply this property, you can get as integral 0 to pi by 2 cos per 4 of 0 plus pi by 2 minus x dx. Meaning you will get back sine. What I'm saying is the same formula for cos and sine is same. Formula for sine and cos is same. So for cos also it's the same only. So remember that also. Why? Because you can apply this property. You can apply this property, then you will get back sine only. Okay, now you can do it. You will get 3 into 1 by 4 into 2 into pi by 2. Final answer is 3 pi by 16. Okay. These concepts please keep in mind. Okay. Now there's another Bornese formula. Also you should know that formula. This is one formula. Second formula is, suppose you are having mixture of sine and cos. Integral 0 to pi by 2. You are having sine power mx into cos power nx dx. How to evaluate this? Look at this carefully. You will have m minus 1 into m minus 3. Then you will have n minus 1 into n minus 3 int divided by m plus n minus 2 like that into k. K is pi by 2 if both m comma n are even, and it is 1 other cases. This is a formula when you are having mixture of sine and cos. You're having mixture of sine and cos, this is a formula. Okay. So I don't think I'll explain like how I explained, This is the basic, like this very similar, you can write. So this is one question I'll do in this 0 to pi by 2. Sine, what to say? Take something, sine power 4x, cos power 5x dx, do it. Someone wanted to do it. Only one question we are doing, then we'll proceed to next concept. Fast. Tell me the answer fast, I will proceed the concept. Otherwise, I'll also be slow. On.
3 into 4 into 2.
Yeah, 3 into 1. You write 4 into 2.
4 into 2. And denominator 9 into 7 into 5 into 3 into 1.
5 into 3 into 1 into 1.
A is 1.
Yeah, because the only time this will be pi by 2 is if both are even. Even if one is odd, it's not pi by 2. Odd, that's good. See? So then evaluate the integral, okay? Cancel. Anything else you can cancel? No. 8 by 63 5s are. Do it. 65 5 these are 15, 5 6 are 31, 30. That's it. 4. So this formula you should know. Okay. This formula You should know. Okay. Now, give me a minute. So this is all about basics. Now we'll see geometric interpretation. I'll just start another recording.